Hello and welcome. In this video session, we will discuss on write system call. Write system call is used to write data from user space that is defined in the program to the file. In order to use write system call, user has to include unistd.h in the program. This is the syntax of the write system call. The write system call takes the parameter fd, which is the file descriptor of the file opened using open system call, and it takes pointer to the buffer which contains the data to be written to the file, and third argument count is the number of bytes of data that needs to be written on the file from the buffer. As a note, the buffer needs to be allocated in the user space. On fail, the system call returns -1, and upon success, the write system call returns the number of bytes written to the file. The argument of write system call is similar to the argument of read system call. The buffer points to the address of the data that has to be written to file. The user has to copy data to the buffer, and count is the number of bytes that needs to be written to file, and fd is the file descriptor of the file which is opened from open system call. Hence, in order to write any data to file, one must first open the file and get the file descriptor, and then pass this handle to read or write system call to perform any read or write operation on that particular file. The buffer argument supplies the address of the memory buffer containing input data. This data is written to file specified by fd. Thus, buffer must be at least count bytes long. This means the buffer specified in write system call must be sufficient enough to hold number of bytes mentioned in count. For example, if user has specified count equal to 10, then buffer must have at least 10 bytes of data that it can hold. The buffer can be more than count number of bytes specified by the user, but not less than count number of bytes. Now, let us see the working example of write system call. In this example, we are going to show the write system call using a C program. This is a program to write data to the file, and the file is existing file. Here we are not creating a new file, and we append the data to the existing file. Let's see the example using oappend and otrunc mode. Here we are including the required header files, and we have a buffer of 100 bytes and copy the user defined data to the buffer using string copy library function. We open the file output.txt in write only mode, and we also have append flag. So in case of append flag, the old contents of the file is not discarded and new data is written from the end of the file. Here, if the open system call fails, we display the error on the screen and exit the program. Upon success, the open system call returns the file descriptor, and using this file descriptor, we write the contents to the file. So here in this example, buff holds the user defined string that needs to be written to the file, and we specify the number of bytes to be written to the file using string length library function. If the write system call is success, it returns the actual number of bytes written to the file. Now let us compile this program and execute to see the output. We have successfully compiled the program. Now let us check the contents of this file. The file contains some predefined data already. Now let us execute this file. Now let us execute the program. After executing the program, it shows the number of bytes that is actually returned to the file. Now let's check the contents of the file. If you see here, this was the old data that is present in the file. To this, we have appended the new data. Now let's run the program once again. Now if you check the output file, these two lines were previously present and this is the new line added. So append, when we write the program in append mode, it appends the contents from the end of the file. Now there is other mode which is truncate. In truncate mode, the contents of the file is written from the beginning. That means the old contents are discarded. Now let us see the example of the same. Now this is the example where we are using truncate mode. Now let's compile the code once again. Now before executing the program, let's check the contents of the file. So these are the contents of the file. Now let's execute the program. Now let's check the output once again. So if you see here, these three lines have gone and the new line that is present is being written to the file. So the truncate mode writes to the file from the beginning, discarding the old contents. As a note, we can also see the manual pages from the terminal. To look into the manual pages, we have to type and followed by the manual page. For example, this page gives the manual pages of write system call, the header files that needs to be included, and it gives details of all that needs to be followed. This can be used as a good reference. Now let's see open system call in the same way. So this is the open system call, which this specifies the syntax of open system call and the header files that needs to be included. In the same way, we can also check for read system call. This is the syntax of read system call and it gives the description of the read system call. Now let us see some more example of write system call. In this program, we are opening a file called as new_out.txt, and in this case, if the file is not present, we are creating the file using o_create flag, and we have specified the o_append mode, and when the file is created, it is created in 774 permission mode, and in case the file creation has failed, it returns a -1. The open system call returns a -1 and we display the error and exit from the program. If the open system call is success, we get the file descriptor of the file that is being created, and now we write the buffer. The contents of the buffer is written to the file using the file descriptor, and then we close the file in the end. Now let us compile the program and see the output. We have compiled the program. The name of the file is write2.c and we have generated the output called write2. Now, before executing, let us see the file new_out.txt. Now let us check the contents. There is no file called as new_out.txt. Now let us execute the program. Now after executing the program, let's check the contents of the file. So now we have created a file which was not present and we have written the contents from the program that is present here. Sample file write is been written to the file. Now Let us execute the program once again and check the contents of the file once again. If you see here, this was the old content and we have appended the new content, the file. This is because we have used the o_append mode. Now let's do a small experiment and see what happens if we do not specify any of the o_append or o_create, o_append or o_truncate, sorry. Now we have specified only o_create without append or o_trunc mode. So now let's compile the program once again. We have compiled the program. Before executing, let us delete the old file. Now we don't have the file new_out.txt. Now let us run the file. Now we have ran the program and the program is run successful without any errors. Now let's check the contents of the file. Now if you see, we have created the file new_out.txt and the contents are being written to the file. Now let us execute the program once again. Now let us check the contents of the file. If you see here, the new contents are not appended. This means if we do not specify append or truncate, then by default the truncate mode will be considered. Join me in the next class. We will discuss on LSEEK and close system call. Thank you.